In September 2020, a team of scientists announced a discovery that sent shockwaves through the scientific community. They had found something in the atmosphere of Venus, something that by every known law of chemistry should not be there. And the only explanation they could come up with was one that most scientists were not ready to accept. Today we're going to talk about what they found, and why it matters far more than most people realize. Venus is not a place you would choose to visit. It is, by almost any measure, the most hostile environment in the solar system. The surface temperature is around 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure is 90 times that of Earth, equivalent to being nearly a kilometer underwater. The clouds are made of sulfuric acid. The atmosphere is thick with carbon dioxide, creating a runaway greenhouse effect that has turned Venus into a planetary oven. If you were somehow transported to the surface of Venus without protection, you would be simultaneously crushed, cooked, and dissolved in acid. It would not be a pleasant experience. Every spacecraft we have ever sent to the Venusian surface has been destroyed within a few hours of landing. For most of the history of planetary science, Venus was written off as a dead world, geologically active perhaps, but utterly inhospitable to life. The surface is certainly sterile. Nothing we know of could survive there. But the surface is not the only place to look. And this is where the story gets interesting. About 50 kilometers above the surface of Venus, something remarkable happens. The temperature drops to a relatively mild range, between 0 and 60 degrees Celsius. The pressure drops to something comparable to Earth's surface. The sulfuric acid clouds are still there, which is a problem, but the physical conditions, temperature and pressure, are actually within the range that life on Earth can tolerate. Some scientists have speculated for decades that if life ever existed on Venus, it might have retreated to the clouds as the surface became uninhabitable. Floating microbial life, drifting in the upper atmosphere, surviving in the relatively benign conditions of the cloud layer. It sounds like science fiction. But then came the announcement of 2020. The team, led by astronomer Jane Greaves of Cardiff University, reported that they had detected phosphine in the Venusian atmosphere. Phosphine is a molecule made of one phosphorus atom and 3 hydrogen atoms. On Earth, it is produced in 2 ways, by industrial processes and by anaerobic microbes, bacteria that live in environments without oxygen. It is found in swamps, in the guts of animals, in sewage. It is, in a very real sense, a signature of biological activity. And it had been proposed years earlier as a potential biosignature for Venus specifically, a molecule that if detected there would be very difficult to explain without invoking life. The detection of phosphine on Venus was startling because there is no known non-biological process that should produce it there. The team looked at every possible geological and chemical explanation, volcanic activity, lightning, photochemical reactions in the atmosphere, and none of them could account for the amount of phosphine detected. The only explanation that fit the data was biology. Living organisms floating in the Venusian clouds, producing phosphine as a metabolic byproduct. The announcement made headlines around the world. Scientists who had spent their careers studying Venus were stunned. Even skeptics admitted that the finding, if confirmed, would be extraordinary. Now, it is important to be clear about what this means and what it doesn't mean. The detection has been controversial. Other scientists have questioned the data, suggested that the signal may have been weaker than initially reported, or proposed alternative chemical explanations that haven't been fully ruled out. A subsequent reanalysis of the data suggested the phosphine signal might be less strong than originally claimed. Science is a process of debate and verification, and this finding has not been confirmed to the satisfaction of the entire scientific community. It may turn out to have a mundane explanation, or it may not. But here's what's significant. The fact that the finding is even plausible. that scientists are seriously debating whether there might be life in the clouds of Venus tells us something important about how our understanding of life's possibilities has expanded. A generation ago, this conversation would not have happened. Venus would have been dismissed out of hand. Today, it is a serious scientific question being investigated by serious scientists with serious instruments. And Venus has another surprise in store. When we look at its history, we find that it was not always the hellish world it is today. Models of Venus's early climate suggest that it may have had liquid water on its surface for as long as 3 billion years, longer than life has existed on Earth. It may have been a habitable world, perhaps even a pleasant one, for most of its history. The runaway greenhouse effect that turned it into an oven may have only kicked in relatively recently, perhaps 750 million years ago. In geological terms, that's not that long ago. For most of the history of the solar system, Venus may have been Earth's twin in more than just size. If Venus was habitable for 3 billion years, and if life got started there as it did on Earth, then life on Venus had an enormous amount of time to evolve and adapt. As the surface became increasingly hostile, as temperatures rose and the oceans evaporated, life would have faced an existential challenge. Could it have adapted? Could it have found refuge in the clouds, evolving the ability to float in the atmosphere and survive in the acidic high-altitude environment? We don't know, but the question is no longer absurd. It is a legitimate scientific hypothesis with testable predictions. In 2029, NASA's Da Vinci probe is scheduled to dive into the Venusian atmosphere, sampling the clouds and the lower atmosphere as it descends. It will be looking for signs of chemistry that might indicate biological activity. It won't be able to confirm life. That would require a much more sophisticated mission. But it will give us far better data than we currently have. And it may either strengthen the case for Venusian life or help us rule it out. The European Space Agency's Envision mission, also planned for the early 2030s, will study Venus's surface and atmosphere in unprecedented detail, potentially shedding light on the planet's geological history and the conditions in its clouds. If you're as fascinated by this as I am, make sure you're subscribed, because in the coming episodes, we're going to venture much further from home, to worlds that are even more surprising candidates for life. The story of Venus is a reminder that the universe is full of surprises. The worlds we dismiss as dead may not be. The places we think are too hostile may harbor life in forms we haven't imagined. And the search for life is not just about finding comfortable Earth-like worlds. It's about expanding our imagination of what life can be and where it can exist. Venus, of all places, may be teaching us that lesson. In the next episode, we're going to leave the inner solar system and travel to the outer planets, to the giant moons of Jupiter and Saturn, where some of the most exciting discoveries in the search for life have been made in recent years. The ocean moons of Jupiter and Saturn are next, and what we've found there is extraordinary. Keep watching, subscribe if you haven't, and let's keep going together.